Welcome on to another lesson with Mr. Burns. In this lesson we are going to generalise the simple equations that we have been working through. Okay, so what you should know so far, these are all linear equations, and to solve equations we change the subject to x so that the x, the variable, is on its own. We do this by applying inverse operations. Okay, so as a recap, right, in general these linear equations take the form x plus a equals b, where a and b are a member of the real number line. This was an example that we looked at. By applying inverse operations, we are applying a minus 2. We have to have the left hand side equal to the right hand side at all times. So whatever we do to the left, we have to do to the right for it to be balanced. Keeping this in a nice column. 0, 5 minus 2 is equal to 3. And that is the final answer. X is a member of the real number line also. If x is 3, then 3 exists. 3 is on our number line. Okay, so that was a recap. Now, to generalise this, right, let's just call this number 2. Let's just say it wasn't 2 and 5. Let's just say it was A and B, okay, where all of these are a member of the real number line. But we want to change the subject to x so that x is on its own. And we do this by applying inverse operations on everything else that's affecting x. What's happening to x there? X add a. So what's the inverse operation of adding a? Minus a. Okay. X on its own. A minus a is 0. What's b minus a? Well, we don't know what b is, what value it is. We know it exists on the number line. We don't know what a is, but we know it exists on the number line. So we would just write it as b minus a. And that's a generalisation of what you are doing here. Okay, let me do another one. Let's just say it wasn't A and B. By convention and by preference, we just go alphabetically. You'll notice that. A and B. So let's just say it wasn't. There's certain letters that we just wouldn't use. Maybe like I because it looks like a 1, or O because it looks like a 0. Right, but any letter at all. Right, apart from the ones that would be misinterpreted as something else. So again, pause the video, have a wee go at this one. Generalise x plus d equals f. So what's affecting x? An addition of d. What's the inverse operation we need to apply to that? Minus d. If we do minus d to the left hand side, we need to do minus d to the right hand side so that this equation remains balanced. D minus d, 0, f minus d. Again, we just say that f and d exist on the number line. Then we can write it like that. Now there's a big space here. That's just to show you how you can set it out nice and neat. We like that in maths, and we always underline our answer. Okay, so there's a couple of examples on generalisations, and I'll upload a few more just to let you see how that can change. Okay, thanks for watching.